algebra, and in algebra also we have started with matrices and determinant. Okay. We have started with matrices and determinants, and so these are two chapters basically, but we are only covering matrices for now. Sorry. So we are only covering matrices, and we have had a basic idea about matrices, right, in the first class. So, Faisal, do you have your classes started for class 12th?
Yes, sir.
And what did they start with in maths?
They started matrices, and we're in the first exercise.
Okay, cool. So you have a basic idea about matrices, right?
Yes, sir.
Okay, cool. So we have introduced matrices. Like matrices are basically tables or representation of some numbers, or maybe functions, or maybe variables, complex numbers. It can be anything, maybe vectors, right? So it is a basic representation, and we were actually covering the types of matrices. I don't know how many types we have covered in the last class. Can you please update me? Anyone? How many did we cover in the last class?
3, sir.
4, 3 or 4? Okay, 3. Third one was
Row matrix.
row, column, and square.
Yes,
If I'm
sir.
not wrong. Okay. So, and I think we have also covered rectangular matrix, fourth. In rectangular, we just have to write that number of rows and number of columns are not equal. That is, m and n are not equal, right? So we have this basic matrix, which can be represented as, let's say, the matrix is represented with the capital letter A, and the matrix element is represented as Aij, and the order of the matrix is m cross n, right? So this was our basic representation of a matrix. Right? Where m cross n is read as the order of matrix. This is the name of the matrix, right? Name of matrix, and this is element of the matrix. And in particular, if I say, so this is the element which belongs to ith row, right? This first one is represents the row to which this element belongs to, element of the matrix which belongs to ith row and jth column, right? So we were done with this basic representation, basic definition of matrix, and we were talking about types of matrices. So we learned that it can be called as column matrix or row matrix if there is only one row involved. If there's only one row involved, that is, if the order is 1 cross n. If this order is 1 cross n, then this will be known as row matrix, because there is only one row. If the order is m cross 1, then it is known as column matrix. If there is only one column present in the matrix, right? And if the order is m cross n, that is, the number of rows are equal to the number of columns, then it is known as square matrix. And in particular, when we talked about square matrix, I showed you some of the examples. Like if I write a 2 cross 2 matrix, so this will look like this. A general form of 2 cross 2 matrix is this. Similarly, if you talk about, just a minute. Yeah. So if you talk about another, if you take 3 cross 3, a general 3 cross 3 matrix, so it would be A11, A12, A13, then A21, A22, A23, A31, A32, and A33. So this will be a general square matrix of order 2 cross 2 and order 3 cross 3. Right? Now, the fourth point is if M is not equal to N, then this matrix which we write will look like a rectangle, and hence the name rectangular matrix. So I'll give you an example for this as well. Let's take any matrix A, and which is 1, 2, -3, 4, 7, 9. Now this matrix involves 2 rows, 2 horizontal lines, 2 rows, and 3 columns, 3 vertical lines. So the order is 2 cross 3. Please feel free to ask your queries if and when required. Okay, can we move on further? If somebody is writing, just raise your hand. Whenever I ask, can we move further? You just have to raise your hand. Okay. So we were talking about the types of matrices. Now, after these 4 types, we are going to define some more types. Okay, sorry, just a minute. So in the types of matrices, we're going to talk about next is diagonal matrix. So let's say let's talk about the example we have taken earlier. So this is a 3 cross 3 matrix, right? This is a square matrix because the number of rows and number of columns are equal. Now in this matrix, there are 2 diagonals, right? We have talked about it a bit in the last class. Just for the sake of revising it, let's talk about it once more. So there are 2 diagonals involved. One diagonal is this one, which involves A11, A22, and A33. And one diagonal is this one, A31, A22, A13. Now this diagonal is special. How is this special? Because this particular diagonal involves all the elements which has same row and same column. See, 1, 1, 2, 2, 3, 3. So this diagonal is known as principal diagonal. Principal diagonal. And this diagonal is known as secondary diagonal. Now remember, the concept of diagonal only exists for square matrix. Diagonal exists here only. Always remember this. So all the elements which lie in this principal diagonal are known as diagonal elements. So all the elements which belong to the same row and same column That is 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. If the order was higher, then A44 or A55 or more can be involved. But all those elements which belong to the same row and same column, or rather, you can also say that all the elements which lies on principal diagonal are known as diagonal elements. Now, how to represent diagonal elements? That we'll see here. So fifth type is diagonal matrix. Just a minute. Okay, so this is diagonal matrix. Now, what is a diagonal matrix? So diagonal matrix is that kind of a matrix in which all the diagonal elements. Sorry. First of all, we should talk about this. That in our syllabus, we'll be mostly dealing with all the square matrices, right? So all the square matrices are the area of interest. So whatever we'll talk about, most of the rules or most of the types of matrices even, we'll be talking about square matrices only. So right now we are trying to understand what is diagonal matrix. Just a, yeah. So diagonal matrices are those matrices in which your diagonal elements will have some particular value, but all the non-diagonal elements will be zero. Now, how to represent this? So let's say we have this A matrix whose elements are Aij, right? And whose order is n cross n. So a diagonal matrix can only be a square matrix because we are talking about diagonal elements. As soon as we talk about diagonal elements, right there and then we got to know that the matrix involved is square matrix, right? So A is equals to Aij n cross n is a square matrix. Now, when it will be called diagonal, what will be the situation? So it will be called diagonal. Will be called diagonal matrix. If these elements sorry. So this Aij, first of all, this Aij must be 0. 0 for what? 0 for all I not equal to j. It means that all those elements in which I is not equals to j, that is, let's say I has a value 1, then j should not have 1. J can be 2, j can be 3, j can be 4. That is, now just imagine these elements. What will be these elements? So let's put I is equals to 1, right? If you put I is equals to 1, j can take values 2, 3, 4, 5, 6, 7, because we can't take i's and j equal, right? So for first condition, we are saying when I and j are not equal, the value of this element should be 0. Now, when I and j are not equal, the elements will be like this: A12, A13, A14, A15, up to where? A1n, right? Then A21, A22 we can't take because I and j will be equal. A23, A32, sorry, my bad. It should be A24, A24, A25, up to where? A2n. Similarly, this will go like AN1, AN2. There will be so many elements, right, in which I and j are not equal. Only n elements will be there in which I and j are equal, if you consider it. I and j both can take value 1, both can take 2, both can take 3, both can take up to n. So A11, A22, A33, A44, A55, A66, up to ANN. All of these will be diagonal elements, which are represented like this. Aij for I is equals to j. It combined represents a diagonal element. That is all the Aij's in which I and j are equal. So we are saying, now what are we saying now? We are saying that all the non-diagonal elements must be zero, and at least one should be non-zero. So out of all the diagonal elements, one must be non-zero. If this condition is satisfied, so these all have to be zero. So if this condition satisfies, you can call a matrix a diagonal matrix. Now let's consider some questions, some examples. Let's understand, did you even get it or not? Can I have everybody written this? Somebody's writing, just raise your hand. Okay, let's take some of the examples from diagonal matrix. Okay, so in case of diagonal matrix, let's say we have this matrix. Is it a diagonal matrix? Yes, guys. What do you think about it? Is it a diagonal matrix?
No, sir. No.
Why?
Because the number of rows and columns are different.
Right. So first of all, it is not a square matrix. If it's not a square matrix, how can it be a diagonal matrix? Correct. Okay, let's talk about this. Is this a square matrix? Is this a diagonal matrix?
No, sir.
Why?
Because the diagonal is 0.
All the diagonal elements are zero.
Yes.
One of the element, at least one of the diagonal elements must be non-zero. Then only we can say any matrix is diagonal matrix, right? So this, let's talk about this as well. अभी हमारे पास आगे, do you understand, Faisal? Do you understand Hindi?
Yes, sir.
Okay, cool. So अभी हमारे पास ये आ ही गया है, तो let's talk about this as well. This matrix in which all the elements are zero is known as what? Can someone tell me the name for this?
Zero matrix.
Zero matrix. And there are many names. Null matrix, void matrix. So all such matrices in which all the elements are zero. It doesn't matter the matrix is a square or rectangular or row, column, whatever it is. However, the type or order of the matrix, if all the elements of the matrix are zero, then you can say that that matrix is a zero matrix. Right? So this is, but still, this is not a diagonal matrix. Okay. Is this a diagonal matrix? Yes. What about B?
No, sir.
Why?
Because the non-diagonal element has 2 in it.
All the non-diagonal elements are not zero. Yeah. What about this?
No, sir.
Same problem?
Yes, sir.
Sorry. Can we say now this is a diagonal matrix? Far.
Yes.
Can change the emoji. This is a diagonal matrix. Now, what about this? Is this a diagonal matrix?
Yes, sir.
Still a diagonal matrix, right? Cool. You can write these things if you want to. Otherwise, we'll proceed. Okay, can we proceed? Cool. Okay, let's talk about 6th type of matrix, which is scalar matrix. So scalar matrix is a particular type of diagonal matrix. Scalar matrix is a particular type of diagonal matrix only. What does it mean is that scalar matrix is a subset of diagonal matrix. All the diagonal matrices are not scalar, but all the scalar matrices are diagonal. That is for sure. Now, what is the speciality about scalar matrix? So all the diagonal elements, sorry, all the diagonal matrices in which so let's say this is our diagonal matrix. A is equals to Aij n cross n. Right? This is our diagonal matrix. Right? So in which Aij is equals to 0 for all I not equal to j. But this is equal to k for all I equals to j. That is, all the non-diagonal elements are still 0. All the non-diagonal elements are still 0. But all the diagonal elements must be same in this case. They can't be anything other than 0, obviously. If they are all 0, then this will be a 0 matrix. But other than 0, whatever they are, they all must be same. For an example, a particular type of matrix I would like to show you, which is our 7th type of matrix as well. Identity matrix, we call it. Now, what is an identity matrix? A special scalar matrix in which k is equals to 1. So this is an identity matrix, 2 cross 2 order. Now see, this is a scalar matrix as well, 3 cross 3 order. So scalar matrices are those matrices in which all the diagonal elements are equal and all the non-diagonal elements are 0. While identity matrix is a particular type of scalar matrix in which all the diagonal elements are 1. They are still equal, but they have this particular value 1. Right? So you can define identity matrix as A is equals to Aij n cross n, where Aij is equals to 0 for I not equal to j and 1 for all I is equals to j. Now, another example of scalar matrix can be let's take out this 2 by 3, 0, 0, 2 by 3. Whatever the matrix is, you can also put this as k, but k should not be equal to 0. Otherwise, it will be a 0 matrix only. Zero matrix, by the way, has no significance. We would not like to have a zero matrix anywhere. Zero matrix is always avoidable. Just for the references, just to make you understand how this chapter will be going. We don't want to observe a zero matrix often because it has no use, meaningless. But identity matrix is very important. We would like to go to identity matrix always. This is the simplest form of matrix. Okay, can we move on further? Can you write zero matrix as well? How many types we have covered? 7 or 8. I guess 7, right? Okay, zero matrices. So let's say you have A is equals to Aij. And this can be anything, m cross n. For all I comma j is equals to 1 to m and 1 to n. Basically. So we can actually write it like this. All the elements are 0. So these are some of the types, right? Also, I'll tell you 2 more types. They are not particularly required right now, but they'll be required later on. Just to understand these 2 more types, pretty easy, just like how however, all of this is going, very easy to understand. So 9th is upper triangular matrix and lower triangular matrix. So how does upper triangular and lower triangular matrix look like? This is same. So let's talk about upper triangular matrix. So I'll first show you one of the example. Then we will write how to understand how to write a upper triangular matrix in purely mathematical form. That we will understand a little later. First, let's check how does an upper triangular matrix look like. So okay, so what does upper triangular matrix say? This is our main diagonal, principal diagonal, right? Above this is a triangle. This particular diagonal divides the whole square into 2 triangles, right? Now, upper triangular matrix and lower triangular matrix, in very simple words, are the figures that you observe, right? So just a minute, guys. Yeah, sorry. So upper triangular matrix is generally look like this. That sorry. So this diagonal will divide the any square matrix into two triangles, right? Whenever the lower triangle has all the elements 0, forget about the diagonal right now. Forget about the diagonal. Only focus on the above 3 elements and on the lower 3 elements. These 3 and 3 elements constitute your lower triangular and upper triangle. Right? So whenever this lower triangle is 0, contains all the elements, all these 3 elements are 0. In this 3 cross 3 matrix, I'm just talking about this for now. So in this case, if all these 3 elements are 0 and all the above elements has at least one non-zero value. If all are 0, then this will be a 0 matrix only, right? So if all the lower triangular elements are 0 and the upper triangular elements plus diagonal elements must contain at least one non-zero element. So out of these 6, at least one must be non-zero, and out of these 3, all must be 0. Then this will be an upper triangular matrix. And similarly, the opposite, if you talk about lower triangular matrix, upper triangular elements must be 0, all these 3, and one must be non-zero from all 6, from the lower 6. Right? That's the rule. That is how it will look like. Now let's write this too. How to write these elements? Now let's understand this. This is the first time we are going to write it. We have to understand how to write these elements, how to understand the shape of a matrix, right? So this diagonal is basically dividing this whole matrix into two shapes, right? So this diagonal element contain I and j equal. This whole diagonal elements are, what are diagonal elements? In which belong to the same row and same column. These are diagonal elements. In a square matrix, all the elements which belong to same row and same column are known as diagonal elements, right? So A11, A22, A33 in this 3 cross 3 matrix, A11, A22, and A33 are the diagonal elements. Now all the above elements, focus on these 3 elements. In this case, this will be written as how? A12. This will be written as A13. This will be written as A23. If you focus, A23, right? And now let's focus on these 3 elements. This will be written as A21, this A31, and this A32. The nature of all of the above elements are same. Similarly, the nature of all below elements are same. What's that nature? In all of these 3 elements, let's focus on the lower triangular elements for now. In all these 3 elements, the number of row is greater than the number of column. In first 2, 1, 3, 1, 3, 2. Similarly, in the upper triangular matrix or upper triangular elements rather, we have the number of column greater than the number of row. 1, 2, 1, 3, and 2, 3. So guys, if you do programming, any one of you, if you follow CS programming or follow any language, so in that case also you need to do a lot of programming in matrices. So in that case, how do you read these elements? That is the way to read these elements, like upper triangular elements, lower triangular elements, and then these diagonal elements. All the diagonal elements will be represented as like this. So sorry, yeah, all the diagonal elements will be represented like this, Aij, where I is equals to j. All the non-diagonal elements will be represented as Aij for I not equal to j. Whatever these values are, I'm not focusing on this. No, this is of no use for now. I'm just trying to show you how to write elements. right? So these are diagonal elements. These are non-diagonal elements. Now, non-diagonal elements can be upper triangular or lower triangular, right? Now, in case of upper triangular matrix, so upper triangular matrix will be like upper triangular is alive, lower triangular is dead, right? So in upper triangular matrix, if you have a matrix A, which is Aij, obviously that has to be a square matrix. Then only we can talk about diagonal elements. Then only we have upper triangular elements and lower triangular elements. So A is equals to Aij n cross n. This is our general matrix. Can be known as upper triangular matrix, where if, sorry, I should write if Aij is equals to 0 for all I greater than j. For all I greater than j. For all I greater than j, meaning if you put I2, then put j1. So A2 1. If you put I3, you can take j1 or 2 in this case. So all these elements must be 0. At least one element out of the rest must be non-zero. Then it will be known as upper triangular matrix. Did you understand it? Upper triangular matrix?
Yes, sir.
Yes.
Please feel free to ask any question if you have. Like, please feel free to ask in this class. Don't even worry about it, or don't hesitate about anything. Okay. Just on the picture. So last one is lower triangular matrix. So this will be A is equals to Aij n cross n if Aij is equals to 0 for all I less than j, and at least one element out of the rest must be non-zero. In all these cases, we can call the matrix as low triangular matrix. I'll try to show you an example. This is a low triangular matrix. 2 cross 2 matrix, but still low triangular matrix. 3 cross 3 matrix. This is a low triangular matrix. We are not saying that all the lower triangular elements must be non-zero. You understand this fact, right? We are not saying that all the lower triangular elements must be non-zero. We are saying that upper triangular elements must be 0. And at least one out of all these 6 must be non-zero. Right? So these are the types of elements. These are the types of matrix you will generally see, and you can identify them easily. Right? These are the basic types. Now let's talk about some of the algebra of matrices. Right. Can we move on further? If someone is writing, just raise your hand. Okay, cool. So algebra of matrices. Let's try to understand the algebra of matrices. Right. My bad. We are writing this in first class, chapter 1. Okay, algebra of matrices. So algebra of matrices, basically we are talking about, you have understood the representation, you have understood the basic meaning, you have understood all the basic nuances of matrices. You know what are the small details that are related to matrices, how do you represent it, right? And what are the information that you can store in matrix, right? Now you want to understand what to do with this. Like we understood we can store a lot of information in matrix. Good. What to do with that information? You can store our information a lot. I mean, a lot of ways are there to store your information. Why the matrices is so important? So the fact that all the calculation or all the algebra of matrices is quite simple to understand, easy to understand, and very powerful to apply. So that fact actually leads that we are studying matrices, and that is what we want to understand, that how the algebra of matrices is going on. So what are the operations that we can apply here, right? And how do we observe matrices? Like we have seen a table. What can we do with this table? So first of all, we will talk about equality of two matrices. When do you say two matrices are equal? Now, in general, I'll ask you this question. What do you think about it? Like, when do you see two matrices are equal? You can answer anything. Feel free to answer. Like, okay, I'll help you out. Are these two matrices equal?
No.
Why? I mean, my argument will be, just listen to my argument. My argument is that I have taken the sum of all these three, 3 plus 2 plus 1, which is 6, and taken the sum of all these three as well. So I am basically combining the matrix to 6, 50, 6, 15. My argument is this. So according to me, I think they are equal. What is your argument? Why are not they equal?
Both the matrices should have their order equal.
Yes. So first of all, A has 6 elements and B has only 2 elements. How can they be equal? If you talk about equality, the number of elements of first matrix should be equal to the number of elements of second matrix. We should start it from here. Now, for that, I have another argument. If let's say 1, 2, 3, 4, 5, 6 is the first matrix, contains 6 elements, I'm giving you exactly 6 elements in the exact same order. Oh, consider this 1, 2, 3, 4, 5, 6. But are they equal now? A and C. Why far?
Because one is 2 cross 3 and one is 3 cross 2.
So another, I mean, if you are going to think about whether they are equal or not, we would see whether we can compare them. I mean, are they even comparable? So in this case, if you think this has 2 rows and 3 columns, and this has 3 rows and 2 columns. So if they are comparable, which element is equal to which? They are not comparable. right now, because this row has 3 elements and this row has only 2 elements. So if we talk about equality of two matrices, first thing first, order of the two matrices must be equal. They should look like same. At least they should look like same. If they are not even looking in the structure wise, I mean, if their structure is not same, how can they be equal? If their structure is same, then we will only think about whether they are equal or not. Right? So let me erase them because that was only for your understanding. So if you talk about equality of two matrices, order must be for two matrices or two or more matrices to be equal, their order must be same. Order must be same. Right? And second is, if order is same, then corresponding elements must be same. Corresponding elements must be same, माने same position पे same number. तो दोनों एकदम look alike होनी चाहिए actually एक दूसरे के, तभी हम दो मैट्रिक्स को equal बोल सकते हैं, right? This is very easy to understand. So I'm just going to write this in mathematical terms. So if you are saying the two matrices are equal, so let's say first matrix is Aij n cross n. Then second matrix will be Bij. Can you tell me the order of B? What should be the order of B if they are equal? Tough.
N into M.
N cross n. Their order must be same. Now, by corresponding, we mean for all Ij 1, 2, up to n. Corresponding elements means A11 must be equal to B11. That is, first of first element should be equal to first of first element of second matrix. All the corresponding elements must be same. I'll give you an example how to use this. So just a second. Actually, I'm using one of the first time. So equality of two matrices, right? Now let's take an example. We have this matrix A, which is x plus y, 2x plus 3. Sorry, I would make it complex. And then this is a z minus t. And then this would be z plus or 4z plus 3t. And then this is equal to 37, 21, 16, 40. My bad. Sorry. Just so we have two matrices A, x plus y, 2x plus y, z minus t, 4z plus 3t. And then there is another matrix B, which is 37, 21, 16, and 40. If A and B are equal, so you have to find x, y, z, and t. If A and B are equal. Now, can you tell me if A and B are equal, what does that mean?
X plus Y equals 37.
All the corresponding elements are same. If you are saying two matrices are equal, it only means that all the corresponding elements are same. So if A is equals to B, it implies that all the corresponding elements must be same, which means we have four equations. X plus y is equals to 37. Then 2x plus y is equals to 21. One set of equation is this. Another set of equation is z minus t is equals to 16, while 4z plus 3t is equals to 14. This is simple pair of linear equation into variables. We have done this. We solve it and find out the values of x, y, z, and t. Guys, please feel free to answer as soon as you get it. First one is quite simple. Yes. Anyone? Iram? Fahad? Anyone? Question number one. Tell me the values of x and y. This is very quick. Just have to subtract first equation from second. This will give you x is equals to minus 16 directly. If x is minus 16, y must be 53. Now answer the second one. हाँ जी, एनीवन? किसी को आंसर नहीं मिला? अच्छा, सॉल्व ही नहीं कर पा रहे हो? वाओ. हाँ, so multiply this first one with 3 ना, and just add them. So this will be 7z. This will be 48 plus 14, 62. Z will be what? 62 by 7. Right? No? What would be t? T would be what? Minus something negative. This would be z minus 16. 16 into 7 will be 112. 50 minus 50 by 7. These should be the answer. So you have to use equality like this. Okay, let's find out this as well. Just a minute. Just a minute, guys. This is your A matrix, and this is your B matrix. So these are two questions actually. First question is if matrices A and B are equal, and second question is if A and C are equal, right? You have to find all the possible values of x and y. So B matrix is 0, 0. Then this is just a minute. In the first case, this is your A and B matrix. Sorry, I would also like to make it tougher. X, Y, and K. Now solve this first. As soon as you get this, then we'll be able to go on to the second part, A and C1. This is your C. Guys, did you understand the question? No. Okay, so the question is in two parts. We have three matrices A, B, and C, right? In the first part, we are given that A and B are equal matrices. And with the help of this, that A and B are equal, we have to find all the possible values of X, Y, and K. X, Y, and K. Now, the second part is also same, but the operation or the values need to be found out with the help of A and C. In second part, you are given that A and C are equal. Then you have to find out the value of X, Y, and K. Now try to solve this. This is a good question. You guys can do it, just think about it. First of all, start solving the basics. There are many colors. I don't even know these colors. Just a minute, guys. Yeah, anyone with the answer? Iram, Fahad, Faiza, Mohammadin, Tarif, anyone? Mohammadin, we can solve this, right? Or no?
No, sir. I'm
Why?
trying.
Okay, what are the three equations that you get? As soon as you get A and B are equal, what are the equations that you get? I'm saying that A and B are equal. What does that mean?
Uh,
Start with this. If A and B are equal, what does that mean? It means that their corresponding elements are equal. Corresponding elements are equal माने जो पोजीशन पे एलिमेंट इधर है, जो भी एलिमेंट इधर है जिस पोजीशन पे, सेम पोजीशन वाला एलिमेंट दूसरे मैट्रिक्स में जो भी होगा दोनों बराबर है. फॉर एग्जांपल देखिए ये वाला फर्स्ट रो फर्स्ट कॉलम, ये भी फर्स्ट रो फर्स्ट कॉलम, दोनों बराबर है. तो as soon as you say that A and B are equal, what does this mean? Now tell me. Try this.
It means that x square minus 8x plus 15 is equals to 0 and x plus y is equals to k, like that.
Yes. So now let's focus with what we have. We have these 4 equations. Now, which are the equations we can solve? Now focus on this. Sorry, no, this is not 5x. My bad. This is y. Now focus on which are the equations you can solve. We can solve first, certainly. We can solve fourth. These two are perfectly solvable. No? What are the answers? From this and from this. ये तो जल्दी जल्दी बताया करो.
3 and 5.
3 and 5, good. And from this? -2 and -3. Now we have to think about these two equations. Now this equation, what is the meaning of this question? Let's understand this. Question मैंने तुम्हें इसलिए दिया क्योंकि देखो 2 values x की मिली, 2 values y की मिली, right? तो ऐसे तो हमारे पास 4 possible solutions होने चाहिए. 4 possible solutions कैसे? एक 3, -2, एक 3, -3, एक 5, -2, एक 5, -3. 4 possible solution. But 4 possible solution में से कोई एक ही particular solution है, ये मैं कैसे बता रहा हूं? I have given you these 2 equations. These 2 equations are justifying that there is only one answer. Now, what is that answer? This equation will tell you x minus y is equals to 6. So, x is equals to y plus 6. So, whatever you take y, x has to be y plus 6. So, आपने y को लिया -2. If you take y -2, x should be 4, which is not there. No. If you take y -3, x is 3, which is there. So, you got the answer y -3 and x3. If we put y -3, x3, all these 3 equations are satisfied. Now this 4th equation, what about this 4th equation? We cannot solve this because we have 3 variables in this equation. Now we can solve it because we have the values for x and y. So the value for k must be 3 plus -3, which is 0. So first solve all those equations which you can directly solve. First and fourth are directly solvable. These were 2 quadratic equations which can be solved directly, which will give you some values of x and some values of y. Now, what is the solution of the question? These middle 2 equations will tell you that what are the values of y and what are the values of x that you need to take. There may be multiple values as well. It may be possible that the 2 roots of first equation are 3 and 4. If the 2 roots are 3 and 4, in that case, y is equals to -2 will give you 4, and y is equals to -3 will give you 3, and both of these will satisfy the question. And in that case, there will be 2 solutions. Did you understand it? Please feel free to ask whatever doubts you have. If yes, then please solve second part. फटाफट एप्लीकेशन करके दिखा दो अगर समझ आ गया तो, और अगर नहीं तो प्लीज बेझिझक पूछो, वो दिक्कत ही नहीं है यार, कुछ सोचने का ही नहीं है, यही सोचने का है कि बस क्या पार्ट समझ नहीं है. तब तक मैं रेनबो वाले कलर्स यूज करता हूँ. So this is a very important information. A and C are equal, A and B are equal. If A and C are equal, then x square minus 8x plus 15 is equals to 0, which gives you again two answers. X is equals to 3 and 5. Then x plus y is equals to, I guess, 0. Or what? Let me check. Oh, sorry, not 0. So x plus y gives you this time 3. Then x minus y is equals to k. So we have to find out k from x and y. So before going to this equation, we have to find out x and y. Then only we will be able to find out k. And our fourth equation is y square plus 5y plus 6, which again we have the answer for. It gives you y is equals to -2 and -3. हाँ जी, बताओ क्या होगा सॉल्यूशन फटाफट. अभी इतना टाइम नहीं लेने का. तुम्हें पता है क्या क्या पॉसिबल वैल्यूज है एक्स और वाई की तुम्हारे पास, और इक्वेशंस भी हैं ये आइडेंटिफाई करने के लिए कि एग्जैक्टली क्या वैल्यू होनी चाहिए एक्स और वाई की. So tell me the values of x, y, and k for second part. Yes, x, y, and k. फटाफट बता दो यार, ऐसे क्यों कर रहे हो. X can take 3 and 5, y can take -2 and -3. Now what should be the x and what should be the y that they can satisfy x plus y is equals to 3. There is another condition na, on x and y. X plus y is equals to 3. So this will give you a specific value of x and y out of this. So what is that? देख लो ना, सिंपल सिंपल x और y ऐड करके 3 कवर है. x 3 हो सकता है, y को -2 लूंगा तो ऐड करके 1 आएगा, y को -3 लूंगा तो ऐड करके 0 आएगा. 5 और -2 लेता हूँ तो हो जाएगा, और 5 और -2 लूंगा तो k की वैल्यू क्या होगी, 7. Guys, did you understand this? Iram, did you understand this? Please feel free to ask wherever you didn't understand. Iram, Faiza, Fahad, Imamuddin, and Tarif, all of you guys. Faiza, did you understand this?
Yes, sir.
So first of all, solve all those equations which are certain. Then find out the possible values of one variable and another, all the variables, however variables are involved, find out all the possible values for those. And then if there is any other condition as well, try to satisfy that. If there is not, then these will be all possible answers. Right? Now in operations, algebra of matrices, the first topic was this, which is equality of two matrices, right? And now the second topic is, so algebra is very easy before multiplication of two matrices. So what we can do is, एक तो हम compare कर सकते हैं दो मैट्रिक्स को equality, या तो equal होंगे या तो non equal होंगे. Equal होंगे कब, जब same order हो, right? और corresponding elements same. तो दो दो मैट्रिक्स इक्वल होंगे, राइट? फॉर एग्जाम्पल, अगर आप देखना चाहते हैं कि दो इक्वल मैट्रिक्स कैसे होंगे, तो ये दो इक्वल मैट्रिक्स, अगर एक ए है 1 2 3 4 और आप कह रहे हो दूसरा बी इसके इक्वल है, तो वो भी 1 2 3 4 ही होना चाहिए। नाउ ए इज इक्वल्स टू, जनरली हम यूज कैसे करते हैं इक्वालिटी का? जनरली हम लोग कुछ कुछ वेरिएबल्स एक मैट्रिक्स में डाल देंगे, दूसरे वाले मैट्रिक्स में कुछ नंबर्स डाल देंगे, then we will tell you these two matrices are equal. You have to compare the corresponding elements, right? Now the second part is हम दो मैट्रिक्स को ऐड भी कर सकते हैं। एडिशन पॉसिबल है, सब्ट्रैक्शन पॉसिबल है, मल्टीप्लिकेशन भी पॉसिबल है, डिवाइड पॉसिबल है। डिवाइड नहीं कर सकते मैट्रिक्स में। सो अगर हम एल्जेब्रिक ऑपरेशंस की बात करें, कंपेयर कर सकते हैं, कब कर सकते हैं वो आप जानते हैं, ऐड कर सकते हैं दो मैट्रिक्स को, सब्ट्रैक्ट कर सकते हैं, मल्टीप्लाई भी कर सकते हैं, राइट? और एक और बात, मैट्रिक्स की कोई वैल्यू नहीं होती, कोई वैल्यू नहीं है इस मैट्रिक्स की 1 2 3 4। ये एक रिप्रेजेंटेशन है 1 2 3 4। देयर इज नो वैल्यू अटैच्ड टू दिस ए, कैपिटल ए, नो। तो यार एडिशन और सब्ट्रैक्शन बहुत ही सिंपल है, बहुत ही सिंपल है। एडिशन ऑफ टू मैट्रिसेस इज बेसिकली पॉसिबल ओनली व्हेन देयर ऑर्डर इज सेम, दे शुड बी लुक अलाइक, एक जैसे होने चाहिए, द स्ट्रक्चर शुड बी सेम। सो ए is equals to aij, and let's say this order is m cross n, and so write like this, consider a this and some other matrix b which is bij, and it has an order p cross q, can only be added if, so first part is m is equals to p and n is equals to q, that is order must be same। जब तक स्ट्रक्चर ही सेम नहीं होगा तब तक यू कांट ऐड। स्ट्रक्चर अगर सेम है तो यू कैन ऐड, एंड हाउ टू ऐड? How to add will be simple, just add corresponding elements with corresponding elements. Both of these are equal, तो चाहे आप m cross n बोलो या p cross q बोलो, because n is equal to p and n is equal to q, just directly add them। Let's understand this with a very simple example। So let's say we have this a which is 1 2 3 4 5 6, this is b which is 1 2 minus 1 minus 2। can we add a and b right now? Can we add a and b? No, because this has 6 elements, this has 4। No, their order must be same, now we can add them। what will be a plus b? Yes, what will be a plus b? Just add corresponding elements। so this one will be added with whom?
1.
1, this will be 2, then this will be 4, this will be 7, this will be 3 3 11। add the corresponding elements। add the corresponding elements। Similarly for subtraction as well. Subtraction of two matrices. Same rule. Only two matrices can only be subtracted if their order is same. अगर order ही same नहीं होगा, structure ही same नहीं होगा, तब तो नहीं कर पाएंगे. अगर order same है, तो हाँ बिल्कुल हम ऐड कर सकते हैं या तो हम ऐड कर सकते हैं, सब्ट्रैक्ट कर सकते हैं. एंड सेम जैसे ऐड किया था, करस्पॉन्डिंग एलिमेंट्स को ऐड करते हैं तो करस्पॉन्डिंग एलिमेंट्स को ही सब्ट्रैक्ट भी करते हैं. That is order must be same. Yes, add और सब्ट्रैक्ट करना तो बहुत ही सिंपल है. अगर आप a माइनस बी लिख रहे हैं तो वो होगा करस्पॉन्डिंग एलिमेंट्स को सब्ट्रैक्ट करके लिख दीजिए. ऑर्डर दोनों का सेम ही है तो वही ऑर्डर रहेगा जो पहले था. फॉर एन एग्जाम्पल, अगर a हमारे पास ये है, so a minus b, and now I want to calculate a minus b. How do I calculate a minus b? Very simple. If a and b have same order, then only I can find out a minus b. Yes, they have same order. In this case, this must be 2 minus minus 1. A minus b will be 2. First element is 2. This first element is minus 1. So first minus first will be 3. Minus 2 minus 3 minus 5. 9 minus 15. So that is how we can subtract and add two matrices. Very simple. Just their order has to be same, and add or subtract the corresponding elements. Okay. We'll start after this. Now the most important part of matrices is all of the whole matrices is dependent on multiplication of matrices. सबसे important रहेगा पूरे matrices में ये समझना कि how do we multiply two matrices. If you are good with multiplication of matrices, I can guarantee you this, you'll be good with whole matrices as well as determinants, because that is the most important part. So as soon as you get the that part, multiplication part right, you'll be really good in these two chapters. So वो हमारा सबसे important part होगा. We'll cover that in the next class. Also, you need to cover some questions from chapter 3, and we have some of the assignments. Just give me a minute. Yeah. Yes, so let's solve some of these. So second, third, fifth, and sixth. I'm giving more questions. You'll have to solve some of the questions from the assignment. So second, third, fifth, and sixth from 3.1, 3.11, 3.1.1. Third, fourth, fifth, second, third, fifth, sixth. Then after this, find out this second, this third, fifth, not 13th, rather than 13th, consider 14th. Guys, please note these questions. I'll check on these questions in the next class. So second, third, and fifth, 3.1.2. Second, third, fifth, 11th, 12th, and 14th. Then from here you can take question number 16. Okay. Also take 17. Okay, after this we'll cover in the next class.
So,
Yes,
where should we submit this?
sorry.
Where should we submit this?
You don't need to submit it. I don't know about submission or not, but I'll check these questions. I'll tell you how to, I'll tell you about the submission part in the next class.
Okay.
Okay. And also we have an extra class this week because I couldn't have the last week's Wednesday class. So we'll have an extra class this week. Will it be possible on Saturday or something? We have only one class, right?
Yeah, it's okay.
Cool. चलो फिर मिलते हैं परसों.
Thank you, sir.
Thank you so much.
Sure.